start off and
Thank you.
then pass things on to Roger Culver.
We'll have to do a little technology swap after I'm done talking, so be patient with us on that. But yeah, we're going to try out a little warm-up talk on current astronomy news in the months to come. Of course, we're closed in July, so we won't have one that month. Next month, unless something big breaks in astronomy, we'll probably go over the recent gravity wave discoveries and kind of see what that is. And I'm here for questions. You can hit them with questions too. So tonight's topic is the new Earth-like planetary systems that have come along. That does not mean there's life or they're habitable, but at present we have about 3,600 exoplanets and about 2,700 stellar systems that have been discovered. Not all of those are absolutely going to turn out to be planets in the end. There may be 10% or so that are false positives, but we're working on those, nailing those down. 610 multiple planetary systems like ours. We have 8. Poor Pluto. This suggests there's about 100 billion, maybe as many as 500 billion planets in the Milky Way. That's a rough estimate, but every place we look, we find things going around stars, so that's kind of nice. And maybe around 10, 11 billion potentially habitable planets. Our nearest one that we believe is habitable is called Wolf 1061c, 13, 14 light years away, but I'm not talking about that one tonight. Going to talk about Proxima Centauri b and the TRAPPIST-1 system. Proxima Centauri is part of the star system and the closest star system to our sun, so that's really fun. It's 4¼ light years away. Got 3 stars in that system. This is a dim red dwarf. It was discovered and announced in August 2016, Chile. It has a mass just a little bit more than Earth, 1.3 times, and a radius roughly our size, maybe a little smaller, maybe a little bit bigger. Much closer to the star than Mercury is in our system, because again, it's a very small, dim, cool star. It goes around that star in just about 11 days. So that means that one face of that planet's probably always looking at its sun. So there's a little diagram comparing Mercury's orbit over here and this mini system here with Proxima b right in there. The green belt is the area where the temperatures would be theoretically right for a planet to have the conditions that we would like to see for life as we know it. If you have a big planet with a big atmosphere, you could go from maybe further out, getting some warming and like that. But it's located down here in the Centaurus system. There's Beta right there. I'm sorry, yeah, Alpha Centauri. That's the wrong place. The arrow needs to be over there. Bad slide. I'd say there's an artist's picture of what it might look like sitting on that planet and looking towards the dim red dwarf. Pure imagination, but it's pretty to look at. TRAPPIST-1 is our other solar system or stellar system. There's a bunch of planets here, from something really hot and close to the star up to something really cold further out. Again, going around a dim red dwarf. Was there a question? No. 39 light years away. It's going to be really tough to get just 4¼ light years away. We're looking at ways to get micro probes shot at high speed out there, but these are trillions and trillions of miles, so it's hard to get across interstellar distances, so this is a lot harder, 10 times further. Discovered in segments, we had the LaSalle Observatory, TRAPPIST, and then Spitzer Space Telescope. Added some planets to that. The inner planet's year is only 1½ Earth days long. The outer planet in the system, 20 Earth days. They're rocky, they range from about 3/4 of the radius of Earth up to a little bit more than our radius, and the mass about under half to 1⅓ more. Again, tidal locked. They're so close that they probably have one face pointing in towards that star. Is there water? Are there atmospheres? These are things we're working at. We're trying to get more data, and it's just going to take some time before those announcements come along. Again, here's an artist's picture of what this system would look like from a super perfect telescope of some gigantic size from the Earth, looking at all these little guys crowded in around the star. Its star is not much bigger than Jupiter. Here's the Galilean moons around Jupiter. Here's the TRAPPIST system. Here's our rocky planets, and the size of our sun being much larger. This is a very mini version of a solar system like ours. Here's Mercury. All these little rocks are right down in this little area here. The green belt is the proximate Goldilocks zone where temperatures, again, could be right for life. F is our favorite here. In fact, they even have some ocean in this artist picture here, and then ice around here. If it's tidally locked, you've always got the sun overhead here, probably storms, convection there, then you've got permanent wobbling cold front, and then an icy icebox in the back. Here is where it's located. Here's the Great Square of Pegasus up at the top, go down through Pisces, and there you are in Aquarius. A little circle right there. It's pretty close to our ecliptic, path of our sun and moon and planets. And here's an artist's picture from that F planet, that favorite one in the middle of the Goldilocks zone. Again, pure imagination of what it might look like, but you've got their ocean and some icebergs and like that. Question?
Is it pretty hard to tell if a planet planet is rotating so far away? You know what I mean?
It is. Yeah, what you would probably, if you can start to figure out if there's an atmosphere, or goodness, future telescopes giving us some albedo change and brightness, maybe you can get some of that figured out over time. But yeah, right now that would be pushing it. Yeah. Any other questions?
So can you explain tidally locked?
Tidally locked. Our moon is tidally locked. The one side of the moon's got a little more density, and if it wants rotated at a speed much greater and showed all sides of the moon at some point, every time that denser part came by, the Earth tugged it, sped up a little bit, slowed down a little bit, and eventually you end up with, like our moon, one face facing the Earth all the time. This would be one face of the planet pointing towards the sun all the time. So if you were there, the sun may do some little pattern or not move much at all in the sky throughout the year.
But the implication is that the density has to be non-uniform.
Correct. Yeah. Pretty hard to get a perfectly uniform sphere, so it's a good, that when you're that close, that would happen. Good question. Any other questions? That's all I have. So thank you very much. Praise God over there. You, there you go.
Okay. Okay, how's the audio? Can everybody hear? Okay, couple of comments on the introduction. I taught astronomy at Colorado State University for 50 years. And the question I've been struggling with all through that 50 years and even now is whether it was dedication or stupidity. And it was great fun. I loved it dearly, and I still do love astronomy. And I'm delighted to be here this evening, and I appreciate the invitation to come in and talk with you people. A little bit of history on this talk. Last January, the Northern Colorado Astronomical Society invited me to talk at their January meeting. And the temperature was 11 degrees and it was snowing. And we had like about maybe 8 people show up for the talk. The dinner was canceled. I didn't get a dinner out of it. And so I thought, all right, well, I was invited, to talk here to the LTO group. And I thought, all right, it's May, what could go wrong? And so I'm glad it cleared off, because the prediction was for it to snow through the afternoon, and I was going to start looking at my emails to see if they canceled it out. And and then at that point I would have wondered, did God really want people to hear this talk, in some fashion?
So we're not going to book him in June, though.
Pardon? Well, I'm free. I'm retired, baby. No, I'll be happy to come back and talk maybe about something else. But anyway, this is a topic that I've sort of been mildly interested in, but last year, or about a year and a half ago now, one of my graduate students, my master's students in astronomy up at Colorado State, after he graduated with his PhD from the University of Texas, wrote a 2-volume compendium on this topic, these extinct constellations. And so that sort of gave me the idea to, this is a very interesting topic, and so I sort of looked at other references and sort of built the talk that you're about to hear. And it's very interesting. Astronomy is one of the few sciences that has a deep depth of dimension that you don't see in a lot of the other sciences. And one of those dimensions are the constellations. People looked up in the sky and they imagined that the star patterns made pictures in the sky, which we now refer to as constellations. Now, they're not always constellations. There are groups of stars that are referred to as asterisms, which are sort of parts of constellations in the sky. The Big Dipper, we're going to show the Big Dipper here in a minute, where it's not the entire constellation of Ursa Major, but a part of it. The Pleiades in the constellation of Taurus. The Circlet in Pisces, a little circle of stars. So you have these asterisms, which aren't full constellations, but nonetheless star groups, and they have pictures. And so what I'd like to do then is to talk about okay. All right, this is the Big Dipper. And this is what the sky, without any labels or anything like that. Here are the stars of the Dipper. Here's the bowl, here's the handle, and down here is Polaris, and then this is the Little Dipper down here. And you can look at the sky, and out of the more or less random arrangement of stars, you can imagine pictures. And the Big Dipper is a very good one, because what you can do is imagine different, we think of it as a dipper, okay, with a bowl and a ladle. But the medieval English regarded this as a plow. Okay, here's the blade of the plow, a handle. In the Arab culture, this is a coffin followed by mourners. And in biblical interpretations, this is Job's coffin, followed by, again, mourners. And then the one that I enjoy the most is that in Chinese culture, the bowl of the Dipper is a wagon, a cart, which has government officials in it. And the lobbyists are following the cart. And the point that the Chinese made, okay, and this is over almost 3,000 years ago, and to show you just how much things have not changed, the reason that they thought this is because this cart and the lobbyists went around the North Celestial Pole, never getting anywhere, never accomplishing anything. And so you have then all these kinds of pictures that one can make out of the sky. And this is a good example. Some of those constellation pictures are very obvious. Scorpius is a very, very good one, and it's in the sky right now as you get into the evening. But here's a star chart for the stars of Scorpius. Okay, and you can see, here's the tail, and here's it even has a heart, a star called Antares, which is the heart of the scorpion. Now the problem with that is that the scorpions are arachnids, and they do not have red hearts, okay, and red blood, so there's a little bit of an error there. And these stars from Libra are the claws of the scorpion. And so if you match that up, this is an artist's conception here, here's what the scorpion looks like. And virtually every culture that knew about scorpions had this star group portrayed as a scorpion. Except in the oceanic cultures, the Melanesians and Polynesians and Micronesians. This was Maui's fishhook, and Maui was, of course, a very big player in the mythologies of these cultures. Another example is in the winter sky is Orion the Hunter. Here are the stars of Orion, and Orion is very nice because it has some of the brightest stars in the sky. And here's the belt of Orion. This is the shoulder of Orion, and so you can sort of see this nice, very trim, slim warrior type. And in just about every culture, he was either a mighty hunter or a warrior or some person of considerable strength. And then here's the head of Orion, and so here's again a kind of a stereotype athlete type, as you have a little tiny head, but from here on down, gangbusters, okay, kind of thing. And so, but again, every culture saw this as at least in the northern hemisphere, saw this as a portrait of a great warrior. Particularly the Native Americans have this group as a great warrior. This is an artifact from Central Europe, roughly about 2000 BC. It's called a sky disk, and it's the interpretation of it. This clearly is the moon, and possibly the sun here, but up here there's this group of stars, and there are 7 stars, and so this is thought to be, at least by most archaeologists, to be a rendition of the Pleiades. And so people were making images of the sky very deep into antiquity. Most of the time they were images or constellation or star pictures of the signs of the zodiac, because there was where the sun and the planets and the moon moved, and so any depiction of these star groups, these constellations, that became very important along the ecliptic for the constellations. This is a group of, or a star map from ancient China, and this is about 600 BC. And you can see, all right, here are the sort of the stars of the Big Dipper. You can see that, so this is one of the very oldest Chinese star maps that we have access to. But it's not just in China, but worldwide. This is a star map from the Ojibwe tribe, which is in northern, just southern Canada, right north of the Great Lakes. And they had a very extensive population and culture. And so here are some of the star pictures from the Ojibwe tribe. And the Lakotas are another tribe that have an extensive star maps and star lore. And so this is a universal kind of activity. Okay. Now the first real serious organization that from our standpoint in modern times comes from this fellow. This is Claudius Ptolemy, who was an Alexandrian Greek astronomer. He lived about 150 AD and did all kinds of stuff. He wrote a text summarizing the state of astronomy in the 2nd century AD, which is called the Almagest. And then he also wrote, to the delight of the astrologers, a summary of the state of knowledge in astrology called the Tetrabiblos. And so he was kind of working both sides of the street in terms of the astronomy astrology thing. And what he ended up doing was introduced a total of 48 star pictures, okay, which were distributed as follows. 21 of them were located north of the zodiac. 12 were located right on the zodiac. In other words, these are the 12 signs of the zodiac. 15 were located south of the zodiac. Now, he was in Alexandria, which wasn't that far north of the Tropic of Cancer. And so he had access deep into the southern hemisphere. And so he was able to see and conjure up some constellations that were not that easily accessible from more northerly latitudes. And it turns out all but one of these constellations are on the list of modern constellations. The one that is missing is a constellation called Argo Navis, which is a ship of the Argonauts. And that one actually got split into 4 constellations. We'll talk about that in a little bit here. The primary star pictures or signs of the zodiac. This is a Persian zodiac from about 1300 AD, I should say, AD. And you can see the signs. Here's Libra, okay, and here's, let's see, what do we got here? Here's Sagittarius and Capricorn and Scorpius. I got 2 scorpions there. That's what threw me off. Libra and so on. And Leo's got spikes on him. It looks like a kind of a dinosaur kind of thing. So anyway, so this most of the constellations up until the Middle Ages were basically signs of the zodiac, and that goes all the way back into Mesopotamia. There are constellations of the zodiac and carvings and all kinds of artifacts from that time. Okay, then we come to the Renaissance. And the Renaissance, they started to do star atlases. And here is the a star atlas, the cover of a star atlas, and this was what was called well, here it is. It's Harmonia is the name of the star atlas. And I mean, boy, there's all kinds of stuff going on there. Okay, you have people looking at the sky and the angels with their cross staffs and so on. And this was the cover of this star atlas. And so this was a typical kind of decorative approach to mapping the skies. And so another example here is Johannes Bayer. His atlas was Uranometria, and he was the one. This was in 1661. Or no, let me. I can't read the Roman numerals. I used to be able to do that. Let's see. It's 16.
Yeah, I think you're right.
I think you're right.
Yeah, 1601 is. 1661. Or 16. Let's see. Wait a minute here. 1603 is what it says here, and so that's 16. No, it's 1661. It looks like, yeah. But all right. Anyway, again, the point to be made here is, again, you have this very fancy, very decorative color on the cover of this atlas, and this is pretty cool stuff. And what happens is that people, here's the sky, here's one of these pages of these atlases, that the sky is now filled with all kinds of constellations, okay, and star pictures. And it almost gets too busy here. And so what we're going to talk about then are the constellations that people put into these atlases during the Renaissance and during the scientific revolution. Okay, so roughly from about 1500 to about the early 1800s. And you have people, if there's a space like right here, you've had people fill that in with a constellation of some sort or other. And so those are the constellations that we're going to be talking about, because clearly different people had different constellations for different parts of the sky. And so that had to be brought into some sort of an organized effort. Okay, this fellow, his name is John Hill. His dates are on the portrait. And he was a botanist, a very successful botanist, and his main claim to fame was in botany. But he then also, and as people did in the Renaissance, one of the finest compliments I think you can pay anybody is to call them a Renaissance man or a Renaissance woman. And that basically means that they are very, very good in a bunch of different things. And John Hill was one such person. He was an excellent botanist. He mapped the sky, and he published an atlas of the heavens containing all of the ancient and modern astronomy constellations. And he introduced a number of new constellations, and here are a few of them, okay? And there's an eel up there, and a slug, okay, a toad, and a limpet, okay, there are all kinds of neat stuff. But unfortunately for John Hill, none of these survived. They didn't make it to the final cut. In fact, this is the only place in this particular atlas that you see these constellations proposed. Here's an interesting one. This fellow, Julius Schiller, he was a lawyer, okay, out of Augsburg, Germany. And he tried to Christianize the sky. And so what he did is here's the Christian heavens. And he had, first of all, along the ecliptic, were the constellations that were renamed for the 12 apostles. Okay, so the 12 signs of the zodiac were now the 12 apostles. And the constellations south of the equator were constellations that were of the Old Testament, and the constellations north of the equator in Schiller's rendition were from the New Testament. Here's a good example. Here are the apostles along the zodiac. Okay, up here you have the St. Peter's fishing boat. Here are the three wise men, the Magi. Okay, down here is the Ark of the Covenant. Here's Abraham, and here's the Noah's Ark down here. And so you had all of these, the whole heavens became Christianized, okay, with this guy. And so that introduced a bunch of new possible constellations. Now the problem then, one of the problems is if you have all these constellations, that there are spaces. You have irregular outlines like this. This is an outline of the constellation of Leo, but there are spaces around here. Right in here, for example, between Leo and Leo Minor, you have unclaimed spaces. Well, some people, cartographers would put in constellations just to fill up the space, okay? And so this is an example of Leo with sort of unfettered boundaries, or not formal boundaries. These are the boundaries of Leo after the IAU proposal or declaration in 1927. And what the IAU did was to formalize the number, names, and boundaries for the 88 constellations which were now recognized worldwide by astronomers. Now sadly, many earlier constellations thus became bygone constellations. Okay, and so what we'll do there is talk about a little bit about each one of, or at least some of these bygone constellations. So just as right off the top, all of Hill's constellations and all of Schiller's constellations are bygone. Nobody recognizes them anymore. They were not part of the final IAU cut list. So, okay, the first group actually are constellations that have either been split up or altered in some fashion. And the primo example is Argo Navis. Okay, this was one constellation, the ship of the Argonauts, where the Argonauts were going to try to get the golden fleece in Greek mythology. And it turned out that this is a fairly sprawling constellation right near the South Celestial Pole. And it sprawls over a lot of the Milky Way and in a lot of the most dense parts of the Milky Way. And so astronomers fairly quickly recognized, and particularly with the age of photography, where you could photograph the sky and bring up a gazillion stars in one plate, and in particular along the Milky Way. And so if you're trying to name, for example, variable stars, I mean, even right now, the constellation of Sagittarius has something like 16,000 variable stars. And so if you have a constellation like Argo Navis, you would just have several tens of thousands of variable stars. And that's just one problem. So astronomers decided, well, we're going to break this up into 4 constellations. And they include the Carina the Keel, and Carina is actually a pretty name for a girl, okay? And the Stern, okay, Puppis the Stern, Veil of the Sail, okay? So here's Veil of the Sail, this is the Stern, and the Keel is along here, and then the Pyxis the Compass is right in here. So the Argo Navis is no longer there. It's one of Ptolemy's original constellations, but it no longer exists. It's actually been broken up into 4 sub-constellations or lesser sized constellations. And so it's, like break up the Yankees or something like that, And so, let's see here. And so I backed it up, okay. Okay, another one is a constellation that is called Vulpecula, the fox, and then Answer the goose. And in renditions, this is not a really good slide, but that the fox has the goose in his jaws, okay? And so this was a combination of the fox and the goose. And then this alternately in various atlases was listed as just the fox and the goose individually, or the fox and the goose combined. And then finally they discarded the goose, and so it's just Vulpecula, the fox. Then there are triangulums. And there actually at one time were 3 triangles in the sky. The triangulum, which we now recognize in the northern hemisphere, and then there's Triangulum australis in the southern hemisphere. But at one time, the northern triangle was actually 2 triangles, Triangulum major and then Triangulum minor. And the minor got dropped from the list. Okay, now this is a shot of Tycho Brahe, a very famous astronomer from the Middle Ages during the Scientific Revolution. Tycho was a nobleman from Denmark and is a very, very colorful character. I used to tell my students that if you really want an interesting term paper topic, this is the guy. He was quite a character. He, for example, got into a duel when he was in his youth, and he got his nose sliced off. And so he had 3 noses that he put on. One was a wooden nose for his everyday life, and then a silver nose for sort of important occasions, and then a golden nose for really very, very special parties and state dinners and that sort of thing. And what he did is over 35 years, constructed the very best naked eye observations of all time. And he provided Johannes Kepler with the data that Kepler used to ultimately fashion his laws of planetary motion. it's an ideal, it's a textbook example of science at work. You have somebody getting very, very accurate data, and then somebody else coming along and saying, hey, I can put this into a working theory. Now, the point here is that Tycho, one of his basic and big-time instruments was what's called a wall quadrant. And so this thing actually extends up a quarter of a circle around, and you have a pivot here, and so this pivot can be moved along this quarter circle. And most of you don't remember, but there was a day about maybe 30 to 40 years ago where if you were in a physical science lecture room, you had a huge slide rule at the front of the class. And the reason that was is that that slide rule could give you very, very accurate numbers because of its scale and size. And it's the same thing with Tycho. He was able to measure star positions to the limit of accuracy of the human eye, which is about 1 arc minute or so. And so he was very, very instrumental in basically establishing the heliocentric model for the solar system and lots of other stuff. And so as a result, and what people began to do in the Middle Ages, they were so proud of their accomplishments, is that they decided that they would name constellations for either pieces of scientific equipment or some other achievement. And so this is Quadrantus Muralis, okay, which is the mural quadrant, which was basically Tycho's instrument, and this is again a constellation no longer there, but there is a residual, and that is that there's a meteor shower in early January. It peaks at January 3rd and 4th, called the Quadrantids. And so there was an effort made to rename the Eta Boötes, but that didn't work very well, and so these are popularly referred to as the Quadrantid meteors, and they peak in January 3rd and 4th each year. Okay, another example of and again, this is not a very good slide, is a commemoration of Herschel's telescopes. And here's the telescope, and it's right below links here. There are actually 2 or 3 of these Herschel's telescopes in various atlases. And in one case, there's a reflecting telescope, or 2 cases, there's a reflecting telescope, and in one case, a refracting telescope. And so, and Herschel basically used reflecting telescopes for the most part. But at any rate, so here's one rendition of Herschel's telescopes. Now, this has survived in the modern constellation of telescopium, which sort of satisfied anybody that used a telescope could, got included in that as a result. This is a neat one. This is the electric generator, and it is, let me get this right here, Machina Electricia. Okay, and it's right below Cetus the whale, and here it is here. And again, it is this fascination on the part of Renaissance astronomers with the accomplishments of the day. Okay, electricity was just beginning to come into its own in the late 1700s and early 1800s, and so that was very... And this is another one, unfortunately, that didn't make it. Okay, this is Globus Aerostaticus, a hot air balloon. Okay, and this was named, there was a fellow named Lacaille, a French astronomer, who named this for the 2 brothers, and let me... The Montpellier brothers, okay, who were Frenchmen, who first successfully launched a hot air balloon with passenger aboard and then landed it safely. And they did a lot of work with hot air balloons in the late into the early 1800s. And so this is Globus Aerostaticus, the hot air balloon. It is no longer with us, unfortunately. That's one of the ones I would love to have seen make it, but it didn't. Okay, this is really cool. What also happens, in addition to commemorating scientific and achievements and astronomical achievements, and by the way, Herschel's telescope was put into the play because Herschel had just discovered the planet Uranus, okay, in the late 1700s, and so this was in commemoration of that. Okay, this is Robus Carolingian, okay, and this is the King Charles Oak, okay, Charles Oak is the literal translation, and the story behind this was that in the middle of the 1600s, Oliver Cromwell, well, first of all, Oliver Cromwell took over when there was a revolution in England in which King Charles I was beheaded. And so after people stumbled around, what was called the Cromwell's Commonwealth was founded, and Cromwell was basically a dictator. I mean, he's famous for going to the Parliament, and he said, "You've sat here, you've done nothing, so there's no reason for you to stay here," and basically dismissed them. And so there was an attempt in 1660 to overthrow Cromwell by Charles I's successors, Charles II. And there was a battle. There was a battle at Worcester in which Oliver Cromwell beat up Charles II's armies from Scotland. And so Charles II hid in an oak tree. Okay, and so in commemoration of that, he escaped to France and then returned to the throne in 1660. And the restoration, or I'm sorry, 1650, the battle occurred, and in 1660, the restoration in England. And so he was restored to the throne of England. And at that time, there was a fellow named Edmund Halley, for whom Halley's Comet was named. And Charles II was a patron of Halley. And so Halley said, "Hey, you know, let's commemorate this event with King Charles Oak," okay? And actually, Halley was very enamored of King Charles because one of the stars in a constellation called Canis Venatici, the hunting dogs, is named Cor Coroli, the heart of Charles, Charles's heart, which is a fairly bright star and a very bluish kind of star. So anyway, this is the Royal Oak, or it's called the Royal Oak or Charles Oak. It's in the southern hemisphere. Here's Argo Navis, and here's the Royal Oak. This is another one. This was a constellation proposed by Bode, famous for Bode's Law in astronomy, and I like to think of Bode's Law as kind of the astronomical equivalent of the Holy Roman Empire in Western civilization. And when you were in Western Civ class, that you learned that the Holy Roman Empire wasn't holy, it wasn't Roman, and it wasn't an empire. Well, Bode's Law wasn't invented by Bode, it was invented by a guy named Titius, and it wasn't a law. And to some extent, it's kind of debated with these new solar systems that are being discovered. It'll be interesting to see how that all shakes out. But at any rate, what turned out that Frederick the Great of Prussia died in, let me get the number here, in 1787, or in 1786, and in 1787 Bode named this part of the sky, this is Andromeda down here, named this part of the sky Frederick's Glory. Okay, well, as you can imagine, that didn't play very well in Poland and France and a couple of other places, and so that one didn't make it ultimately. Another one, again, we're looking at royalty here. This one is Salterium Georgium, King George's harp. Okay, and this is George III, who was a patron of music and patron of astronomy. He was the guy that was paying for the Herschels to do all of their research, and they did some very, very important things. And he's pilloried, of course, in U.S. history books, but I mean, a guy that's willing to support astronomy can't be all bad, okay? So I think it was Grenville and Townsend and all those other guys that were. But anyway, this was a constellation proposed by Edmund Halley to commemorate his patron. And that didn't make it. There are rivers in the sky. This is the Tigris and Euphrates River. There are other rivers. There's the River Jordan. There's the Indus River, and there's the Nile River. We're all and here's the rivers, and like the Tigris and Euphrates, they join up and go into the Persian Gulf. It turns out that the Nile River, which was a straight north-south river in the heavens, was named for the Nile River in Egypt. And so that evolved into the modern constellation of Eridanus, okay, the river. And it flows, the stars of Eridanus start in northern Orion, and they're just to the west of Orion, and they flow all the way into the southern hemisphere. And the source of Eridanus is a bright southern star called Canopus, okay, which is kind of cool. This is a constellation called Mons Manieus, which is a mountain dedicated to Pan in Greece. The person standing on top of the mountain is Butes, the herdsman. And so there's actually a mountain up there in the sky, and that one didn't make it. Okay. This is a constellation that was variously named Noctura the owl is the one that is portrayed here, but this was portrayed as a mockingbird, a swift, about 2 or 3 other kinds of birds sitting on the tail of Hydra. This is the tail end of Hydra. And one of the birds sitting on Hydra, Corvus the crow, that one did make it. Okay, that was a constellation that we still have today. And then there's Musca borealis, okay, the northern fly. There used to be a Musca borealis and a Musca australis, but then the Musca borealis got dumped. But there is a Musca, a constellation of Musca in the southern hemisphere, which is still with us, and presumably looks fairly similar to that if you were to sketch it. And then finally, this is Felis the cat. Now, if you look at the sky, there was a fellow by the name of Lalande, Jerome Lalande, in 1799, looked up at the sky and he says, you know, there are a couple of hunting dogs. Orion has Canis Major and Canis Minor, and there's a wolf, okay, Lupus the wolf, but there's no cats. Okay, you have Leo and Leo Minor, okay, but that's it. And so he was very disappointed that there was no house cat in the sky, and so he proposed this cat. And this is, again, here's Hydra up here, and so he put in Felis the cat. And there are a number of different drawings and versions of this, but it was basically located just to the south of central Hydra. And so the cat, the attempt to represent a cat in the sky ultimately fails, unfortunately for cat lovers. Okay, now, here are some of the constellations that did make the final IAU cut, and there's no rhyme or reason for this. So you look at some of these and you compare them with some of the cuts. Okay, one of my favorites is Antlia the air pump, okay, that one's still here. Calum the chisel, Camelopardalis the giraffe. Now Mensa the Table Mountain, it turns out that the Herschels went down to, or John Herschel went down to the Cape Observatory and was so impressed with Table Mountain outside of Cape Town that he put in this constellation of Mensa. Okay, and that's still up there. Okay, now you have some sort of generic scientific instruments, microscopium, the microscope, and telescopium, the telescope. Pavo, the peacock, well, that's okay. Pictor, the easel. Scutum, the shield. That's the scutum of, that's the shield of a Polish Sobieski, who was a Polish hero. And I have no problems with that. I mean, the Poles have been dumped on, you know, for the last several hundred years, and so it's at least let him have a constellation to commemorate one of their heroes. And so these are some of the, that's just some of them. There's some other ones that are, and the story behind that is something that would probably take a whole nother lecture as to, you know, the politics and everything else, you know, that, for example, the scepter of Louis XIV of France didn't make it, okay, and you know, all the politics that goes into this stuff. And so my last two slides are sort of a pep talk and sort of an advertisement for one of my former graduate students, John Valentine, who was my master's student up at CSU. And after he graduated with his PhD from the University of Texas, he wrote a 2-volume compendium of the constellations that have been lost. Okay, and the first of the was the Lost Constellations, in which he talks about some of these constellations. Here's King George's Harp. Here's that's one of the telescopes of Herschel and so on. And so it's a history of obsolete, extinct, or forgotten star lore. And then he wrote a second text called The Uncharted Constellations. By the way, that is the head of Medusa in the constellation of Perseus. And asterisms, single source, and rebrands. And you can get it from Springer Verlag or Amazon, and if you're at all interested in this topic, these are a good starting point texts. And so, as far as the constellations are concerned, one of the fun things you can do, I'm gonna back that up, because that's kind of a frightening, I got a little kid in the front here. The constellations, one of the neat things that you probably have done this at some level, either when you were a kid or even now, that you go out and you look up in the sky, oh, that doesn't look like so-and-so, it looks like such and such. And I actually used to have a lab exercise in my astronomy class where I would ask the students to go out and pick out a group of stars, map the group, just sketch the group of stars, and write a short paragraph about it, and then invent a star picture for that group of stars, and write a legend or a story of how that star group got to be put in the sky. And one of the more interesting ones, I got lots of interesting results, but one of the most interesting was, and this was back in the days when it was illegal, but one student wrote about Marijuana, the marijuana plant, okay? And so, and it was an interesting legend too about it, and this was back in the days when pot was illegal here in Colorado. So anyway, that is and this is only a very small portion of the extinct constellations that are up there. I mean, as you can imagine, there are all kinds of different cultures. I mean, we talked about Western civilization and the Renaissance, but you go to the Native American cultures. I mean, here you look up here, the Polynesian cultures. I mean, just all kinds of different people looking, and of course they see different things in the sky relating to what their experiences are, and these legends and this folklore gives astronomy, I think, a depth of cultural depth that you don't see in the other sciences. I mean, physics does not have that. Okay, certainly medical science, alchemy, and chemistry does, but some of the more modern sciences, and so it's one of the really neat aspects of astronomy, and one of the reasons that I loved it and have loved it for more than 50 years and hope will continue to love it. So Okay. That's, and questions? Yes, sir.
I think that's Cygnus there. The stars I see there within that goose are they all associated with that constellation? Certainly, if you look in the sky with a telescope, you'd see far more stars.
Oh yeah. Well, these are beginning telescopic astronomy. We're in the 15, 16, and 1700s, and so yeah, and you'll find a lot of naked eye stars there will be constellations with no naked eye stars, but there you go down to 6th or 7th magnitude and you start seeing these stars.
And then any star within that constellation would be associated?
Well, but then that's the other problem, is that these boundaries were, until they were formalized by the IAU, you could, I mean, for example, if I wanted to put answer in here, over here, in other words, cut off the wing here or something like that, and these different atlases had different markings and different boundaries for these constellations, and that's one of the reasons that the IAU, International Astronomical Union, had to formalize these boundaries. Yes, sir.
I just think that it's interesting that you point out that there is a lot of history and it stays there. But what it really is the name of the stars, because there's so many stars that you can have names from all of the different cultures.
Oh yeah.
For example,
Well, mainly we get our stars come twofold. There's a lot of Arabic names, okay, Aldebaran, okay, Altair, and so on. But also Bayer was one of the first, in fact, was the first person who started naming stars by designating with letters of the Greek alphabet. Okay, and so you have Alpha Centauri and Beta Scorpii and so on. And you get down, however, after you run out of Greek letters, okay, now you have to start numbering them, 1, 2, 3, and so that's one of the ways you can get around that. But not every star has a name. Most of the naked eye stars do have some sort of name, mostly Arabic names.
and so why is that? Why Arabic?
Well, because they basically inherited Ptolemy's stuff, and they were very interested in astronomy. The Islamic astronomy was ascendant. I mean, they were in very, very good shape from roughly about 900 AD until the beginning of the Renaissance, and they were kind of the caretakers. And so, but they also did a lot of stuff of their own, and so those names carried over. When they got together into places like Toledo in Spain, where you had the Christian scholars on one side and the Muslim scholars on the other, which would be, it's a nice model, for present day times. But it turns out that there's a lot of exchange of ideas, and so those Arabic names stuck. I mean, and they're kind of neat.
It's interesting about Scorpio because in Libra, so I guess Libra came along later because the two main stars are Zubel Venubi, Zubina Shamali, which are left hand and right hand.
That's right. That's right. And what happened is that the Romans came along, okay, and so they wanted a constellation to commemorate the scales of Roman justice, okay, and so that's how Libra got started. And so, people just, play around with these things, and like you say, because those are now stars, the principal stars in Libra, but they were once a part of Scorpio.
So are all the IAU boundaries squares and rectangles?
Well, they're rounded off, yeah, they're so that you have a constant declination and a constant right ascension. It's a lot easier that way, because otherwise, and the other problem that you start running into is precession, okay, because stars you have these star groups, and so as the constellation precesses, the stars move around, and so you have to sort of precess the coordinates as well. Yes?
So you kind of mentioned this about there are constellations that some you can see naked eye, some that you can see with only certain levels of magnitude. I presume
No, there are stars. There are stars that you can see with the naked eye, and then a lot more stars, obviously, with the telescope.
Constellations with different, like you can make constellations with the naked eye stars, and you can make constellations with the...
No, pretty much the naked eye stars run the show on that.
Okay.
Now, what people do, and you'll see articles like in Sky and Telescope or Astronomy Magazine, where they'll have asterisms where you can imagine, like say there's one of the more famous ones is a star group called the coat hanger, okay, which has a kind of a shape like that. And there's all kinds of these things, but they're mostly asterisms, and again, it's in the eye of the beholder. And that's what's fun about it. You can go out any night of the year and look up and say, I don't think that's Seven Sisters, I think it's something else. You know.
So there are no constellations that you can only see with the telescope?
No. No, they're all marked, well, because you've carved up the sky with the naked eye constellations. And so you can see fainter stars in that constellation, but and you can, in your imagination, make up star groups, star pictures out of that. But there are no constellations that you can't see with the naked eye, because that's the origin of these. Is that these cultures were seeing these things and making these star pictures.
That's
Yes?
what I was asking before. If you have a constellation with, say, 7 stars, and then you get a telescope and you see 100. But they're within that constellation. Are those stars then associated with that constellation?
Yes, indeed. Yes, indeed. Yes. For example, our Lyra is a variable star in the constellation of Lyra, and it's in those boundaries, and so that's it. Yep. Yes, sir.
Has a constellation ever been lost due to a star either dying or having its...
I'm sorry, again, please?
Has a constellation ever been lost due to its star, one of its stars dying or...
No, because usually, well, in the olden times, if it was a bright star, nothing like that happens. It doesn't happen that often. But now these constellations are defined in terms of zones in the sky. And so it doesn't make any difference what happens as long as it's in that zone. And so those zones will stay. And it's sort of, think of it in a kind of terms of that if you have the whole sky, let's say, and it's the whole world, okay, then you carve up the world into different countries. And so that's basically what the astronomers do. This is kind of an intermediate step from the whole sky down to individual stars or something like that. And nowadays, of course, you have coordinates, right ascensions and declinations that pinpoint anything, and it does make any difference what constellation it's in. Anything else? Well, thank you for having me.